Alright, today we're going to talk about section 3.2, the critical points on the sine and cosine graphs. These are going to be things like the location of the maximum, the minimum, and where the theta intercepts are. So if we think about what we talked about yesterday, breaking this down into quadrants, when I take my sine graph and I think, okay, piece 1, piece 2, piece 3, piece 4, representing the 4 quadrants. So these kind of represent quadrant 1, quadrant 2, quadrant 3, and quadrant 4 as we go around the circle and where these are located. How do I relate that to my frequency and my period? So because there's no b value in here, it's assumed to be 1, which means my period is going to be 2 pi over 1 or 2 pi. When I have to start locating my critical points, I'm always going to divide my period into 4 equal parts. So if I take 2 pi over 4, I get pi over 2. Sometimes it will be easier to take that number and multiply it by 1/4. So just recall that multiplying by 1/4 and dividing by 4 are the exact same thing. What this means is that the length of each one of these sections is pi over 2. So if I go to my graph, this is 1 pi over 2. This piece makes 2 pi over 2. This piece makes 3 pi over 2. This piece makes 4 pi over 2. And the pattern continues, 5 pi over 2, 6 pi over 2, and it continues on and on and on in both directions. Now, the similar thing with the cosine function. So the only difference is the cosine function starts at the max, but you have the max to the middle to the min to the middle, and the middle to the maximum value. And each one of these represents quadrant 1 on the unit circle, a quadrant 2 on the unit circle, quadrant 3 on the circle, and quadrant 4 on the circle. So again, my b value is 1, which means my period is going to be 2 pi over 1. And if I need my midline, my intercepts, my maximums, and my minimums, I'm going to take and divide that into 4 equal quadrants. So as long as there is no vertical shift, I can take 2 pi over 4, and I get pi over 2. Now if you look, I have an x-intercept at 1 pi over 2. This point is 2 pi over 2, my minimum. So the minimum of -5 occurs at pi. Here we're at 3 pi over 2. This is 4 pi over 2, which is the same, reduced as 2 pi. This point is 5 pi over 2, so on and so forth. The other thing you should consider is, how do we go from one maximum to another? So from here to here, this distance right here is the same as 1 full period, which is 2 pi. So if I wanted to think about that, I have multiple maximums. So like this, there's not just one. I'm going to go another 2 pi, and then from this maximum to my next maximum is another 2 pi. So today we're going to talk about how to write the location of our mins, maxes, and intercepts so that we can include all infinite intercepts. All right, so let's look at example 1 together. I'm going to go ahead and sketch this graph. So when I think about what's going on here, looking at my equation, I have an amplitude of 5. I like to state my frequency next, so that's the b value, the number that goes with theta, which is directly related to my period. So my period's 2 pi divided by 3. I'm going to come in, I'm going to go ahead and sketch my graph. So I'm going to draw my vertical axis. I'm going to draw my horizontal axis. So remember, this axis is representing theta. My amplitude is 5, so I'm going to go up 5. I'm going to go down 5, and this is my maximum value, and this is my minimum value, so our graphs are going to oscillate between the maximum and the minimum value. So I'm going to have a maximum value of 5, so I know that this graph is going to start at the very top. Now, how do I know where the rest of my points go? Well, for me, I literally just decide, like, okay, this time I'm going to do each quarter of my graph is going to be over 2. So I'm going to go over 2 to the middle, over 2 to the bottom, over 2 back to the middle, and over 2 back to the top. You could go over 3, you could go over 4, you could go over 1. I just kind of try to equally space them out and also give myself enough room to label the things I need to label. I also know that when I get back to my maximum, I am going to be at 2 pi over 3. I want 2 full cycles so I can go either direction. I'm going to continue in the positive direction. And so each section of my graph has 5 critical points. I started at a max, middle, minimum, middle, maximum. And when I get back to that max, directly under that max, 2 pi over 3 plus 2 pi over 3 is 4 pi over 3. If you chose to go to the left-hand side, you can do that. I didn't quite leave myself enough room to go left, so there's that. Okay, so you can connect your graph with a smooth curve. At any point, if I'm going too fast, feel free to hit pause and catch up. All right, so now I have to think each piece of this graph is representing one quadrant of my unit circle. So I'm going to take my period, and my period in this case is 2 pi over 3, and I'm going to divide that into 4 quarters. But remember, 4 quarters is like multiplying by 1/4. So do my little bit of quick math here. And each quarter represents a distance or an angle measure of pi over 6. So I'm going to come in here and I'm going to make my first piece 1 pi over 6. My second piece is 2 pi over 6. Here I'm at 3 pi over 6. 4 pi over 6, which again represents or reduces down to 2 pi over 3. And if you keep going, 5 pi over 6, 6 pi over 6, which is pi. Here's 7 pi over 6. And again, this is 8 pi over 6, which reduces down to 4 pi over 3. So I know what my maximum and my minimum is, because based on my amplitude, my maximum is 5, my minimum is -5. We do not have an x-axis, we have a theta axis, so my maximum and minimums occur at theta equals. I always choose the location of my first maximum or my first minimum. I know that it sounds weird, even if it's 0, but just to create a consistent pattern, my first maximum is at 0, and I'm going to add my period. So in this particular graph, if I think about the distance from one maximum to another, this distance is the length of one full cycle, or 2 pi over 3. So I'm going to add 2 pi over 3 times n. And n, if you recall, is a positive or negative integer, just representing the number of rotations around the unit circle. My first minimum is at 2 pi over 6, which is really pi over 3. So my first minimum is at pi over 3. And if I think about what's going to happen, length from one minimum to the next minimum right here is the length of one full cycle, or one period of my graph. So one full cycle is 2 pi over 3. So I have 2 pi over 3 times n. The x-intercepts. So my first x-intercept, it's also an angle location, so theta equals pi over 6, my first x-intercept. But this time, if you look at the distance between x-intercepts, it's really not a full period. So a full period was 2 pi over 3, but this is really half a period between each x-intercept, because there's 2 x-intercepts per cycle. So 2 pi over 3 times 1/2 is going to give me pi over 3. So this time, the distance right here from here to here is only going to be pi over 3. So I'm going to add pi over 3 times the number of rotations. All right, so that is one example. So I want you to take a minute and I want you to think through example number 2. So hit pause and work through example 2. All right, welcome back. I'm going to work through example 2, and you can check your work as you go. Your amplitude was 3, even though it's negative. Remember, amplitude is always positive because it represents a distance. Your b value is 1/4, which means your period is 2 pi divided by 1/4, which would be 8 pi. Because our amplitude is 3, we're going to have a maximum of +3, and we're going to have a minimum of -3. And really, until I graph my function, I really don't know anymore. I do know that this graph is very stretched out, so when I think about the location of my vertical axis, I'm going to put it pretty far to the left. So 3 and 3, so I'm going to count up 3, and that's going to be my maximum based on my amplitude. I'm going to go down 3, and that's going to be my minimum based on my amplitude. I look at my function. It's a sine function. Sine always starts on the midline, so I'm going to locate my starting point. Because this is a negative sine function, if you look at the sign right there, it means instead of increasing like the parent function, I'm going to decrease first. So when I go to graph my 5 critical points, this time I'm actually going to count over 3, and I'm going to graph my minimum. I'm going to go over 3, midline, over 3, maximum, midline, minimum, max, midline, maximum, and then I'm going to go back to here. And one full cycle of this function was 8 pi, which means the second full cycle would have ended at 16 pi. And you can connect this with a nice smooth curve. Oops, not great, but okay. All right, so now I've got to determine where my maximums and minimums and intercepts actually really occur. So if I take my period, which is 8 pi, and I divide that into 4 equal pieces, each piece is 2 pi. So when I look, here I'm at 2 pi, 4 pi. When I'm at my maximum, I'm at 6 pi, 8 pi, 10 pi, 12 pi, back at my maximum at 14 pi, and then I'm back at 16 pi. So the maximum values occur. My first one is at 6 pi, so I'm going to come up here and I'm going to write 6 pi. And then if I think about the distance from one maximum to the next maximum, that's the length of one full period, which on this particular function is 8 pi. So I'm going to come up here and I'm going to add 8 pi in. My minimums occur right here, which is at 2 pi. Plus, and again, if you think the distance from one minimum to the next minimum is again the length of one full period or one cycle of your graph, so that's going to be 8 pi in as well. Both of these represent the theta axis, so they should both be equal to theta. I call them the x-intercepts. These really hypothetically should be called the theta intercepts. We'll just call that a typo on our part. So the theta intercepts, if you think of your very first intercept, it is at 0. And every 4 pi in later, you have another theta intercept. All right, I want you to hit pause. I want you to do example 3 and come back to me when you're finished. All right, I've worked out example 3. I just want you to double check your work. If you have any questions, you can ask them when you come to class tomorrow. So hit pause and check your work. All right, so what happens if there's a vertical shift? So today we're going to talk about vertical shifts just a little bit. You have to set the function equal to 0, and you have to solve the function to find the theta values. And then we are going to add and subtract the period to each solution if we are on a limited domain. And then we're going to add the period times n for an unlimited domain. So that's not much different than what we were doing before. So let's think about what's happening. So now we have a vertical shift. So we have this -2 to worry about. So I'm going to go ahead and graph my function as normal. So my amplitude is 4. My frequency is 1, and my period is 2 pi. So if I go ahead and graph that, and I think, okay, from here I have a vertical shift down to, oops, I'm not going to have enough room, so let me redo that. So I need to do a vertical shift down 2. So if I resketch my axes, go up just a little bit here. Okay, so I'm going to go down 2. There's my midline right here. So if I think about the equation of that midline is at y equals -2. From there, I'm going to count down 4. So I'm at -6 for my minimum. I count up 4, I'm at positive 2 for my maximum. So right now, I know what my minimum value is. I know my minimum value is negative 2. I'm sorry, my minimum value is negative 6. Check that. And my maximum value is positive 2. I'm not quite sure where they occur, but I know it's going to be where they cross the horizontal axis. Actually, I just said that wrong. That's not where your maximum and minimums are. Okay, so let's go ahead and graph this. So this is a cosine function. It's positive, so that tells me it starts at the maximum. Again, the absolute best way to do these is to go ahead and graph your critical values. So I'm going to go over 2 units. I don't know why. I just tend to always space mine 2 apart so that I can make sure I get both cycles in. Okay, I am not guessing where these points are. These are strategic. I went over 2, down 4, over 2, down 4, over 2, up 4. And it takes 5 points to draw a nice sinusoidal curve. Okay, so the period, the length of one full cycle, please make sure you're labeling this on the theta axis. So 1 full cycle is 2 pi. So when you go from a maximum to a maximum, this is 1 full cycle, and that's going to be 2 pi. And when you go from maximum to maximum, that's another full cycle, which represents 2 pi. Again, we're going to divide my period into 4 parts because each one of these represents one piece of the unit circle. So 1 full period was 2 pi. If I divide that by 4, I get pi over 2. So make sure you're labeling your theta axis. This critical value is at pi over 2. This critical value is at 1 pi over 2. This is at 2 pi over 2. Here I'm at 3 pi over 2. This is at 4 pi over 2. Here we're at 5 pi over 2. 6 pi over 2. 7 pi over 2. And when I get here, it should make sense that I'm at 8 pi over 2. Now, how do I find my horizontal intercepts? I am going to take my function and I am going to set my function equal to 0. So if I come up here and I say, okay, let's take this function and set my function equal to 0. So if I have 0 equals 4 cosine theta minus 2, move my 2 over. So now I have to solve this on my unit circle. So if I think about my unit circle, when is cosine theta equal to 1/2? So that's kind of like right here. When is my x value 1/2? So that happens here and here on my unit circle. So when I think about that, when is x 1/2? X is 1/2 when my theta value is pi over 3. And when my theta value is 5 pi over 3. So if I transfer that to the unit circle over here, I'll use purple, okay, that means this x-intercept right here is pi over 3, and that means this x-intercept here is 5 pi over 3. And now I have enough information to do all of my maximums and intercepts. So my maximum of 2 occurs at 0 and every full period after that. So the period here was 2 pi. My minimum of -6 occurs when theta equals 2 pi over 2, which is pi, and every full period after that. And my horizontal intercepts, which really should be theta intercepts, occur. My first one is at pi over 3 and every full period after that. My second theta intercept is at 5 pi over 3 and every full period after that. All right, that was a lot to digest today. I know you can do it. There's 2 practice problems at the end of your notes, so we would like for you to take a few minutes tonight and just attempt to graph those in your composition notebook. You can take and put some regular graph paper in there, or you can just honestly use the lines in your composition book as your horizontal axes and then draw some vertical axes in there to go with them. So, all right, hope you have a wonderful evening, and we will see you tomorrow in class.